Okay, so let's take a look at some more exotic trig equations that we want to solve. But now I'm going to put a little extra restriction on them so we don't get sort of infinitely many solutions. In these questions, let's just find solutions. We'll find all solutions that are between 0 and 2 pi. Maybe you can't see that. Between 0 and 2 pi. So remember what that means. What that means is you are allowed to equal 0, and you can go up to 2 pi, but not equal to 2 pi. So basically looking from 0 to 360. I just want answers that are in between that range and nowhere else. Okay. Well, the first one I'll take a look at is 2 sine of 3 theta equals 1. Okay, now how would you solve this? Well, the first thing I would do is try to get the sine thing all alone. So let's divide everything through by 2, and I'd see that sine of 3 theta equals a half. Now, since I have that 3 there, what I'm going to do is I'm just going to first of all solve for just 3 theta. And at the very end of the day, I'll just divide everything through by 3. So first I'm just going to find out sine of blank equals a half. What's the blank? Well, okay, and remember, I'm only between 0 and 2 pi. So if you think of the sine function, what have we got going on here? Well, I want this thing to equal a half. So between 0 and 2 pi, there's only 2 answers. One is right here, and one is right here. One of them we should know. We should recognize that, in fact, the sine of 30 degrees, or pi over 6 radians, actually has the sine equal to a half. So that's this one. But then how do we get this other one? Well, it's by symmetry again. Because see that these guys actually have to be sort of symmetric around here. So what I should do is, since this distance right in here is pi over 6, that means that this distance right here must be pi over 6. So I'll take pi and subtract off pi over 6, and that will give me this angle. So one solution is, and I've got to be careful here, I've got to write this whole thing. 3 theta equals pi over 6. But the other answer is right here. Now, how do I get that? It's just the symmetric mirror thing. So I take pi, so 3 theta equals pi, and then I have to subtract the pi over 6. Let me say that again. The idea is these 2 points, these 2 answers are going to be symmetric. So whatever this distance is here, this distance must be the same. So if this is pi over 6, this is pi over 6. So how do I find that exact value? Well, I take pi and subtract the pi over 6. So if I do that, I see 6 pi over 6 minus 1 pi over 6. That's 5 pi over 6. Now, those aren't the answers because that's just what 3 theta equals. What does theta equal? Well, I have to divide both sides by 3, and I see pi over 18. And then the other answer is 5 pi over 18. And that's what theta equals. So when you have a multiple angle in here, you just solve for the multiple angle first, then just divide through, and you get the actual answer. Okay, let's try another example. And again, same rules apply. I'm only looking for answers that are between 0 and pi over 2. How about tangent squared 2x equals 1? Well, if tangent squared 2x equals 1, that means the tangent alone must equal plus or minus 1, taking positive or negative square roots. So where does that happen? Well, here's a rough sketch that I made a while back for the tangent function. And I'm just looking from 0 to 2 pi. So where do we see, that's the only window I'm looking at here, is this. And where do I see this thing actually equals 1? Well, it equals 1. It looks like at 2 places, 1 over here and 1 over here. And where does it equal minus 1? It equals minus 1 in 2 places, 1 over here and 1 over here. So I have to find all those values. There should be 4 answers to this. Well, first of all, where does it equal 1? Well, that's when this value is pi over 4, or 45 degrees. So in fact, what I see here is that tangent 2x equals 1 when 2x equals either pi over 4, which is 45 degrees, or how do I get this solution? Well, it's just a translate of this over by pi. The period here is pi. So if I add pi to that, I should get this value right here. So this is just going to be pi over 4 plus pi, which equals 5 pi over 4. So what does x equal? Well, x equals, so x equals, if I divide through by 2, I see pi over 8. And I also see 5 pi over 8. Those are the values where the tangent 2x equals 1. But what about the minus 1? Well, to find that, tangent 2x equals minus 1. Well, these are the values that are sort of right in here. And how would I find that? Well, what I can do is, well, this picture is maybe a little small. It's maybe difficult to see. But if you think about it on the angle board, the reference angle is still going to be 45 degrees, or pi over 4. But now where am I? Well, where is the tangent negative? All students take calculus. So here and here. So that's where tangent is negative, and the reference angle is pi over 4. So how do I find this angle? Well, this angle is going to be 180, or pi, minus pi over 4. So one answer is 2x equals pi minus pi over 4. That's how I get this red angle. It's by taking 180, or pi radians, and subtracting off that, which is pi over 4. So there the tangent's negative 1. And the tangent is also negative 1 over here. How could I get that? I could just take 2 pi and subtract pi over 4. So the other answer is 2 pi minus pi over 4. And so what do I see? I see that 2x is either equal to, this is 4 pi over 4, minus pi over 4 is 3 pi over 4, or this answer, and this is 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. But that's what 2x equals. So what does x equal? Well, x will equal half of these things. And so what I'm going to see here is 3 pi over 8 and 7 pi over 8. So those are the two answers that make the tangent of 2x equal negative 1. But don't forget the answers that make tangent 2x equal to 1. So in fact, this equation actually has 4 answers in the range from 0 to 2 pi. And I found them by factoring carefully and then looking at the graphs and actually finding the solutions. Okay, let's try one last one. How about this? Sine of 2x times tangent of 2x plus sine of 2x equals 0. And I want to solve that. So I can see I can factor out a common factor immediately of sine of 2x. So let's do that. So sine of 2x times tangent 2x plus 1 equals 0. And so if I have a product of things equaling 0, either sine of 2x equals 0, or tangent of 2x equals minus 1. Okay, so what are the solutions? Well, in fact, if I could only reach that thing, if I could reach that thing right down there, I could actually show you. We already did this one, because this one, tangent of 2x equals minus 1, we just solved that. We saw the answers were, in fact, let me just record that here. We've already seen that x would have to be 3 pi over 8 or 7 pi over 8, because tangent 2x equals minus 1 is exactly what we just did in the previous problem. So I'm just going to use all that work, and I divide through by the 2, and I get that. Great. So all we have to do now is this one. Where does sine of 2x equal 0? Well, where does the sine equal 0? It equals 0 at pi, and 2 pi, and 3 pi, and minus pi, at all the multiples of pi. But I'm only interested, remember, in this particular problem, between answers between 0 and 2 pi. So between here and 2 pi, but I'm not allowed to equal 2 pi, what's the answer? Well, the answer is just 0 and pi. 0 and pi. And so if the answer is just 0 and pi, that means that 2x will equal either 0 or pi. So what would x equal? Well, x would be, when I divide through by the 2, I see 0 and pi over 2. So those are the values that make the sine of 2x equal to 0. These are the values that make the tangent of 2x equal to minus 1. And so what are the solutions to all of this? Well, 0, pi over 2, 3 pi over 8, and 7 pi over 8. So this equation has 4 solutions. There are 4 solutions to this in the range from 0 to 2 pi. And again, the way I found the solutions is first by factoring and then some careful analysis of the more simple type trig equations that we talked about earlier. All right, try these and good luck. These do take a little bit of time and practice, but with a little bit of care, we can all master them. Maybe even me. I'll see you soon.